Hello everyone, this is Sullivan Gaia. I'm the Key Account Executive for the International Market. We are very happy to see all customers attending to this webinar. The colleague that will be presenting this webinar is Fabio Pima, our Product Manager, and also the marketing team, Fernanda and Carol, is over here supporting us. We really appreciate your attention and your time. Please feel free to ask your questions to the chat anytime. This is with you, Fabio. Go ahead.
Hello, everybody. Welcome to this webinar. For those who already know me, hello again. For those newcomers, welcome to our group. My name is Fabio Piuma. I am Product Manager of Novus, and I will present our third model of LogBox Connect family, the so expected LogBox Wi Fi, adding more versatility to Novus portfolio for a wide range of applications of LogBox Connect. One solution for each application. So this is what we are going to talk about LogBox Wi-Fi. It is important to understand what is the motivation for this product, the way how it will solve the customer problem, some attractive features, and some way how it is applicable to meet the customer requirements. With this basic information together with a proper documentation, you will be able to use in your market campaigns and pre-sales effort. Of course, we'll have a time before the end of this webinar to read and answer some of your questions about the product. Right after the end of webinar, we have a traditional quick survey. Please answer it. The survey will appear just after the webinar is finished. Just a reminder, feel free to make the questions you need. We have the marketing product team supporting us during the webinar and they can answer almost immediately online. So I would like to talk about the technology trend for facilities. Environmental or climatic telemetry for facilities is becoming more demanding in order to improve control of surroundings in the processes and to reduce the direct cost of energy. Managers wanted to have the big picture of large facilities or the entire processes. The quality of the processes depend on the operation under center limits. Specific market segments potentially request legal audits from recorded confident data, and those data should be confident. And saving energy is not just a target cost, it is social commitment in some markets. The communication of measuring device should become easy, compliant with the standards trend, and plug and play as much as possible. This scalability is also a must in order to allow the recording of data from several places. For example, like the various rooms among a hospital. Managers also wanted to minimize the impact of installation work of such monitoring and control systems. The use of actual IT infrastructure is certainly preferred. All monitoring nodes must be connected in network architecture. They can be either an IoT device or a SCARA network slave device to allow supervisory control center room for prompt response decisions. Even without using the device as if it were part of an IoT network, using the existing Wi-Fi network on current facilities provides the scalability motivation for taking this advantage, not only for new systems, but also for extension of current systems. For example, on the factory facilities, several devices can be placed to monitor variables. Because of the connectivity, the operator can have online and recorded data and manage this information from the control center or from his own computer on desk. We can say that even today, some organizations have already distributed measurement device, but they are not yet networked on the premises. The operator must walk and annotate in the clipboard manually and then sit and compile all the information for further analysis. These requirements are not reducing. Contrariwise, there is a growing need for connected device for centralized information across all market segments. Adherent to this tendency, LogBox Wi Fi is suitable to meet these requirements, as it may operate as a thing in IoT networks, the Internet of Things, or to be installed in existing IT networks as part of a supervision system. It has MQTT protocol to publish data to IoT brokers or cloud as well as Modbus TCP protocol to operate as slave of SCARA or host of automation systems. Operating in MQTT mode, it provides uninterrupted data logging without lack of data, even in link or power failure. It can also be a device node of SCARA system, easily added to new or existing supervisory systems using the widely used standard Modbus TCP protocol. LogBox Wi-Fi has large non-volatile memory capability, which provides secure local data from failure of power or Wi-Fi link. When in MQTT mode, this means an IoT device, the protocol ensures all logged data during the failure will be published in batch to the broker, and therefore to the data server. Both USB and Wi-Fi interface can be used to configure the device parameters or to perform data downloads. The end experience is the free Novus software for setting and data download. An experience is already available to download and installation on the Novus website and is fully compatible with LogBox Wi-Fi, as well as the other LogBox Connect brothers, such as LogBox BLE and LogBox 3G already available to the market. The difference here is mainly the specific parameters for Wi-Fi configuration and the communication interfaces. The operator can manage the entire network of LogBox or the facilities from his own computer desk. The communication can be performed directly from an experience to all devices, once at a time, using the IP number or a friendly tag, or even a nickname defined by the own user, everything done under Modbus TCP protocol. So easy and friendly as it looks like. Some applications may require the use of SCARA system. In this case, LogBox Wi-Fi is natively compatible with most SCADA solutions on the market. As an example, we can mention the cost-effective SCADA Novus SuperView, an Ellipse E3 from Ellipse Software, in which both already have Modbus TCP communication driver, and the customer may build its own applications. Any other SCADA or supervisory system with this protocol may use a network of LogBox Wi-Fi. It operates under the local Wi-Fi network through Modbus TCP protocol. Another way to use SCADA with LogBox Wi-Fi is with the MQTT protocol, used mainly on IoT device and networks. Why use this protocol instead of Modbus TCP? The answer is that with MQTT, some customer requirements, such as continuous uninterrupted data, are met. That means in the occurrence of a failure of power supply or Wi-Fi link, all data will continue to be logged into the device. And when the condition becomes normal, all data recorded during the fault period will be automatically sent to the broker and then to the SCADA system. Therefore, no data will be lost during the failure. Okay, related to technical features of LogBox Wi-Fi, following the standard input types from LogBox Connect family, it has 3 universal analog inputs. A wide range of sensors can be used, like thermocouples, PT100, and few standard range of voltage and current signals from transmitters. The same built-in sensors are available here: internal temperature, battery voltage, and external power supply voltage. As usual, LogBox Wi-Fi has one digital input that can operate as a pulse counter or event recorder, which means change of state of the digital input. The resolution of the analog inputs is 15 bits, and for the counter mode is 16 bits. It also has a digital output, PNP type, that can switch loads up to 200 milliamps. The output can be configured to operate as an alarm or as an electronic switch to supply source power to signal transmitters from some external source voltage, like a stationary battery, for example. LogBox Wi-Fi can be powered by an external 12 to 30 VDC source, and it uses a backup battery to continue data logging during the power failure with very large autonomy, which means easily up to 2 years of autonomy. LogBox Wi-Fi has a set of alarms. A total of 8 alarms can be set. 2 alarms per channel, high and low set points. The user can define a hysteresis value to avoid unstable output switching. The alarm occurrence can be set to activate the buzzer or just to display warning on screen, or still to activate the digital output. The output may trip an external load or be used as on-off control logic in some applications that require a minimal on control. The memory capability is 140,000 records. The interval of acquisitions can be set from 10 seconds to 18 hours. The memory is secure and non-volatile, ensuring total data integrity. And of course, the available communication interface at USB and Wi-Fi, as mentioned previously. Okay, let's look at some LogBox Wi-Fi parts. We have here some pictures, and we see, following the LogBox Connect style, the terminals are removable to facilitate installation, are protected by a cover. Same as other from this family, it features a wide 3-line display and 2 rubber keys, useful for screen navigation and parameters changing. In the back part, there is the compartment to replace the batteries. The end user can replace by itself. They are just 4 common AA-type alkaline piles. And finally, the Wi-Fi antenna is embedded inside the enclosure of LogBox Wi-Fi. So coming back to usability feature. Let's imagine several rooms in a facility. Each room needs to be monitored. The requirement is to monitor all rooms on a central computer. According to the user requirement, LogBox Wi-Fi provides to the operator the management of data from his own desk regarding all devices from the facilities. The user can perform data collection from any LogBox Wi-Fi in the network with the NXperience software. He can also modify some parameters from any LogBox Wi-Fi in the network. On the other hand, if there is a supervisory software from the customer, the software itself can request or receive automatically periodic data from all logboxes through any of the available protocols. This is the easy and friendly way to manage data from the new user requirement. As usual, Novus offers the NXperience software for Windows platform, suitable to LogBox Wi-Fi and available for download in our website. LogBox Wi-Fi can be accessed via USB port or Wi-Fi network. An experience can use USB from computer or IP connection, either by Ethernet or Wi-Fi local network. It has all necessary features for fully configuration and download from LogBox Wi-Fi data. Besides the already available management of logged files and the formal reports available in the tool. As mentioned before, LogBox Wi-Fi can also be used on SCARA systems. It has been tested with Novus SuperView with Modbus TCP protocol. SuperView is the Novus own SCARA software. LogBox Wi-Fi operates also with third-party vendors of SCADA softwares. Ellipse software, for example, validated communication with LogBox Wi-Fi with both protocols, Modbus TCP and MQTT. So both driver communications options are available for Ellipse E3. LogBox Wi-Fi has features to be used in many applications. Here we mention some examples. Data centers are facilities that need climate monitoring. And because of the high availability that IT providers need to deliver to their customers, the facility needs to be monitored 24/7 with remote access and alarm generation. In case of abnormal situation, the customer will be able to see and take the required decisions. Other application is in industrial environments. Multiple points can be monitored and logged, all connected to the Wi-Fi network. Eventually, if needed, the customer may set up a dedicated Wi-Fi network just for the monitoring devices, so as not to interfere with the various other Wi-Fi devices that also use wireless network. We can set a dedicated network for the network of LogBox Wi-Fi. Other examples of applications are to monitor clean rooms, laboratories, and hospitals. For these facilities, the feature of easy installation is a must. Expanding or improvements in such facilities requires quick deployment to avoid interfering with the daily activities. Wi-Fi infrastructure is becoming more common in these market segments, which facilitate and create requirements for its use and adoption. The last application to be mentioned here is in monitoring for airport facilities. There are many types of applications in airport activities, such airport lounge comfort, rooms for refrigerated cargo, and other applications. Large facilities like this require online monitoring, and LogBox Wi-Fi seems very suitable to this. So now please check again at the LogBox Wi-Fi features. Feel free to make your questions or just listen to other questions. Maybe you're already thinking about specific applications. Think about your customers. And now we are opening the time for your doubts. So I have here a question. What type and what is the autonomy of the battery of LogBox Wi-Fi? The batteries are the standard AA type alkaline piles, and we have an autonomy of up to 2 years. Remember that it is backup battery, and when it's operating in backup mode, the Wi-Fi is turned off just to save energy. And when the main power supply becomes normal, the Wi-Fi is recovered. Okay. Here we have a question that's if the LogBox Wi-Fi is configurable via Wi-Fi. Yes. If, for example, a customer has a network of LogBox Wi-Fi from his own desk using an experienced software, he can configure just using the IP number, access each one of LogBox Wi-Fi and configure. There is another question of if LogBox Wi-Fi is able to send data to Novus Cloud. In fact, we have LogBox Wi-Fi has two protocols: the Modbus TCP that's using in master-slave networks, and MQTT, that's IoT protocol, that's architecture of publishing and subscriber, and this is used by the let's say the common clouds like Microsoft, Amazon clouds, and so on. For this time, we don't have yet how LogBox Wi-Fi sent to Novus Cloud, but we are releasing very soon from now a version that he also will be able to publish on Novus Cloud. Okay, there is a question here about the limit for how many devices an experience can access. There is no limit. It can be any quantity of LogBox Wi-Fi the customer can install in its facilities. The only question is the operation of configuration or data download is one logbox per time. Okay, it can manage any logbox from the network, but it's managed once a time. Just complementing this information, this is for using an experience tool. But if the customer is using some supervisory or SCARA system, of course, if we have a network of log boxes, they can send data simultaneously to the SCARA system or the supervisory system. Okay, here a question: how the MQTT protocol works. It sends it's like an IoT device. It sends to some cloud server. Okay. Just the only let's say question is there is a part called broker. The MQTT device sends to a broker, and the broker sends back to some cloud systems. Okay, the customer can install a broker. We can help the customer to build the broker. This not a problem. Okay, here there is a question about the frequency or let's say the speed of communication. LogBox Wi-Fi is standard 802.11 BGN. So it can operate in B networks, G or N networks. Okay, so it's backward compatible with B, and the new ones N high-speed Wi-Fi networks. There is a question here if the data can be set automatically from the logbox to some server. Because of the architecture, the MQTT can do it. Okay, MQTT push the data to the server. In Modbus TCP protocol, the server asks to LogBox Wi-Fi the information. Okay, so if you want to push the data automatically from LogBox Wi-Fi, should be used MQTT protocol. There is other question if LogBox Wi-Fi can be part of CFR 21 port 11 system. Yes, it can be. Of course, the host system used should be compliant with this standard, and SuperView and Ellipse SCARA systems are capable to do it. Also, LogBox Wi-Fi is able to be part of this standard. Just a information, we are working on turning an experience also compliant with CFR 21. Okay, it will be available very soon. Another question: if all data from memory of LogBox can be read via Modbus TCP. In fact, yes. There are some special commands, Modbus-like commands to retrieve the data. You can do it by an experienced software, and of course it can be done if the customer has how to implement some different protocol, some let's say compliant Modbus commands. But yes, it's possible. Okay, just information that all questions sent here, we have several questions. We are gathering all these questions, and we will answer it in a document that we will send to all the attendants of the webinar. Okay. So people, so thank you all for attending our webinar. Please check our website. We have already released all technical and commercial documentation about LogBox Wi-Fi. Briefly, we will release this webinar itself recorded on the website. You can check it later on. Please contact your key account executive to go ahead with LogBox Wi-Fi. I wish all of you good business. Thank you again, and goodbye.